So for us to appreciate this equipment reliability, we want to know the reason why components fail. We want to appreciate the reason why component fails. So when we know why the component fails, we'll be able to protect the component or the equipment from those stressors, okay, that will be able to give that reason why the equipment or the component of the equipment fails. Now, remember, when designing that equipment, we determine the stress level, okay, that is the condition, normal operating conditions that the equipment will face. Are we getting it? During operations. So we determine the stress levels. It could be temperature, pressure, heat, vibration level, force, stress, environmental condition. In fact, whatever level that we have, the ones that we can actually design out, we actually design them out. But definitely, we try to determine those levels, okay? So once those levels are determined, you see that during production of that asset, those components in that particular asset will be designed to withstand more than that stress level that we specified. Okay, as you can see here, you see if this is the specified stress level or what we expect that the system will face during normal operations, what will be produced at the end of the day will be one that can withstand a very high or a higher stress level than what is specified. So this difference, okay, between what we specified and what is produced is a reliability level or a factor of safety, okay, that is deliberately put into the assets so that we'll be able to operate the asset safely and reliably. So if during normal operations, the stress levels, okay, that we subject the equipment to is around this level, you see that we will have no issues. The equipment will operate till maybe stresses due to age will reduce some of those reliability, okay? So you see that we have no issues. We operate our facility, our asset reliably and safely. So if these are if this is what is usually done, then why are these components failing, or why are these assets failing? Because if that factor of safety is considered while producing that particular asset, why then does it fail? Because it has the capacity to withstand far beyond that level of stress that it is designed for. Okay, so now remember we said we look at various stressors, and at times there are stressors we may fail to actually consider during the design stage, and during normal operations we'll now be confronted with these stressors. Imagine maybe an asset that is designed to operate in a non-corrosive environment is now used in a corrosive environment. So those corrosive components of the environment will now become a source of stress on that particular asset, because it will induce corrosion on the components of the assets, and once corrosion sets in, the integrity of the assets will be compromised because it will no longer be able to withstand that level of other stresses. Are we getting it? Be it pressure, force, temperature, vibration, and what have you. Okay. So if that is the case, why then will component fail? Because if this is the design and this is what it's subjected to, this safety factor should be able to help us to use it to infinity. But the fact is that during normal operations, that envisaged stress level, temperature, pressure, let's take pressure for example. The equipment is designed, maybe we expect that the pressure level that component will withstand is, assuming is 2 psi, and then the component is designed to withstand 4 psi. Ordinarily, if we subject that component to the steady 2 psi, since it is designed to withstand 4 psi, we will not have issues. Is that not so? Yes, of course, we will not have issues. But you know that during operations, there are times the stress level will overshoot that 2 psi. And maybe because of maloperations and what have you, unreliable operations now, or unreliable operator, we may even have up to 4 or beyond 4 psi in the system. Okay, so once that happens, at that moment the component is stressed. Then if the operations is rectified and then the pressure comes down, everything will appear to be fine. But know that the equipment has been stressed. So if such repeats itself again, such repeated stress has the effect of straining that component beyond its elastic limit. So once it goes beyond that, you see, it will not be able to gain back its integrity to withstand that particular stress. Okay, and then the failure mechanism will start setting. You see, because of such events, okay, the strength will start degrading, as you can see on the screen. It will start degrading to the extent that the stressor will now at times will go beyond the strength of the component, and eventually that stress will repeat itself and the component will eventually fail. Okay, so no matter the kind of component you are looking at, even if it is electrical component, remember the insulation is meant to withstand a level of voltage, that is voltage pressure, and the insulation also is meant to withstand a level of temperature. Are we getting it? So when the current flowing through the conductor causing heat because of the I-square R effect is more than what it is designed for, that will also be a stressor to the insulation of that electrical component. Once it is repeated, it will the insulation will degenerate to a stage that eventually it will fail. Are we getting it? So that is how components fail. All components, whether you are looking at electrical components, mechanical components, civil component used for civil construction, or any that you can think of, the stressor, as we said, can even come from the environment outside the process. Are we getting it? So we need to understand this and try as much as possible to determine as many stressors, okay, in our system as we can, so that we'll be able to see how we can guide against those stressors to improve the reliability of our assets. So for us to appreciate further, okay, the kind of reliability program we need to deploy and when in our system, we also need to appreciate the failure pattern Okay, as you can see on your screen, we have 6 failure patterns. Okay, if you look at it, the 3 on the left, they are age related, and they make up for about 11% of reliability problems that we have in our facility. Then the 3 on the right, they are not age related. It can happen anytime within the operations of the assets. Okay, and you can see that they account for over 89% of asset unreliability or the reliability issues that we usually have in the system. So the mistake that we do, because this is the most common failure pattern, okay, that we are all conversant with, and you can see that this pattern is age related. Okay, we have the infant mortality, as we'll see later, and the reasons why we usually have components or equipment failing during the infant stage. We'll also see that later. Then any failure around this area which is random, it is during the normal operational life of that equipment. Then we have this area that is age related. Okay, so you will see that most of us, we feel that the failure of all of these components will follow this pattern. The components of our asset or the failure of our asset will follow this pattern. So if you look deeply, most of the programs, maintenance program that we deploy, they are all meant to catch the component or the asset when it is entering this region. Not even here that accounts for some levels of failure when it is entering this region, as we'll see later. Most of our PM program, our condition monitoring program, okay, most of our reliability programs, they are designed that way. Okay, so you see that if they are based solely on this age related, will be accounting for only about 11% of the failure that our asset is exposed to. So you see, we'll be having frequent unplanned maintenance because of a breakdown failure that is not seen or could not be accounted for. Okay, so if we concentrate on this random, know that the equipment will fail randomly, and then we'll concentrate more of our assets on this part of the curve. You see that we'll be able to take care of 89% of the unreliability issues that we'll be having in the plant. So we'll see that later, okay, as we go along in subsequent section. So you want to know these failure patterns, know why component fails. They fail because they are subjected to a stress level beyond what they are designed for. So the stressors could be anything. Could be temperature, which is closely related with heat. Could be pressure, okay. Could be corrosive environment. Could be voltage. Could be current. You know, current generates heat. Are we getting it? Once that heat is more than what the insulation of that covering that conductor is designed for, that insulation will fail. Even the conductor itself, if it is subjected to current that is more than what is carrying capacity, it can fuse because of that heat, can melt and break. Okay, so it could be current, like we said, could be voltage, the environment, and what have you. So whatever stressors that we compromise the integrity of our system, we want to take care